Okay, folks, I'm sure that I've confused you greatly in class trying to describe the more difficult method to do these shear force and bending moment diagrams. So we're going to do something refreshingly easy and just get ourselves a solution to these problems that's not as difficult. So we already know that if we have a 2,000 kilogram mass, we have to multiply that by 10 to turn it into a force, 10 meters per second squared, which is acceleration due to gravity. So we know that we have a 20 kilonewton force that is acting down. We could calculate the reactions at the reaction at A and the reaction at C, and we know how to do that. Sorry, I've got reaction AC. Reaction at C. We know how to do that. It's a 5-step process, but we also know from previous experience that if we were going to do this free body diagram for a very simple situation like this, that we know that the actual free body diagram would distribute that 20 kilonewtons equally on both sides. So you'd have 10 kilonewtons acting up on this side for reaction A, and you would have 10 kilonewtons acting up on this side for reaction at C. And at dead center, we have our 20 kilonewtons acting down. And we know that our distances are 2 meters and 2 meters. All fairly simple. Now, we're not going to do all that business we did in class and, that terrifying situation of trying to get this to make more sense. What we're going to do is we're just going to do the easy way. So you need to grab a ruler. Please don't do it rough like I'm doing it now, but you need to take these lines where the forces are acting and you need to create lines down your page that are going to be the lines that you're going to line up your shear force and bending moment diagrams with. You would do that with a ruler. Okay, so the first thing we need to do is we need to do our shear force diagram, and I'll go back to black for that. And shear force is going to be on our shear force is going to be here and across to here. Now, the follow the forces method we've done in class, we have a 10 kilonewton acting up. Now, if I started on this side and went up and then across and then down, this side would be positive and this side would be negative. And if I start on this side is positive and this side is negative. And I know that you're going to be saying to yourself, well, how do I know which side is positive and which side is negative and whether I go right or to the left? All you need to remember is, like we've said in previous videos with our sign convention, if the forces are rotating the object in a clockwise direction and our bending moments are doing this, we're looking at a positive situation. So we can see here on this side of the diagram, I'll just step up a bit so we don't ruin our picture that we've created. We can see here that this force acting up and this force acting down is going to cause the thing to rotate this way. And we know that clockwise rotation means we're going to have a, using our sign convention, we have a positive shear force. And on this side, we have a rotation that's counterclockwise, and counterclockwise activity for our convention of bending moments for this particular situation. If we have positive bending moment, but we have a counterclockwise force, we're looking at negative. Okay, so that's how we know. So we don't need to worry about getting it wrong. So on this side, we're going to start on the left-hand side anyway, but we know we're going to go up, and we know we're going up because we have a positive shear force, which we just talked about. We come across until we hit the 20 kilonewtons going down, and then we go down. So this is 10 kilonewtons here, and we've now come down to minus 10 kilonewtons because we had to follow that 20 kilonewton force down. And then we come back across, and then we come back up. Remembering, of course, that at either ends of a simply supported beam, our shear forces and our bending moments come to zero. So that is our shear force diagram. And now we need to do our bending moment diagram. And we know that our beam is going like this. And we've already talked about in class that when we have a bending moment diagram or bending moment happening like that, we have a happy face, okay, which means our bending moment is a positive bending moment, okay. If it's sagging, we have a positive bending, and if it's hogging, we have a negative bending moment, okay. So that's how you remember that. So we have a positive moment, bending moment for this one. So we work out our area underneath our shear force, okay. So we have 10 kilonewtons multiplied by our distance gives us a 20 kilonewton meter value for a bending moment that's positive. So what we do is we know that for a simply supported beam, our value always starts at 0, but then we're going to look at this area here. We're going to say 10 times the 2, which is the 2 meters, and we end up with 20. So we're going to say that's 10 and that's 20, and our bending moments is in kilonewton meters. Okay, so we're going to take our line as a straight line, not what I just did. We're going to take our line as a straight line, and we are going to draw a straight line to that point there. And then we look at our second area, which is going to be identical to the first one. It's going to be minus 10 kilonewton meters times the 2. So we end up subtracting 20 kilonewton meters. That takes us back down to, and like I said before, for a simply supported beam, it takes us back down to 0. And that's how you do a simple shear force and bending moment diagram for a simply supported beam. Pretty simple. Took 7 minutes to do. Look at a few more examples, and we'll certainly do more examples in class.